Third learning target in the chemical bonding unit is analyze and interpret ionic compounds. So earlier we've already learned about ions, which consist of two types, cations and anions. Now it's time to combine them to make neutral ionic compound formulas. So an ionic bond is the force of attraction that creates a chemical bond between ions of opposite charges. We have learned that ions are atoms that have either lost or gained electrons. So there's two types of ions again. So there's monatomic ions. Mon comes from the prefix mono, which means that there's single atoms that have either a positive or negative charge. So monatomic ion and an ion are used pretty interchangeably in terms of vocabulary. And then there's something called polyatomic ions. And a polyatomic ion is a group of atoms acting as a unit, and they have an overall charge. An ionic bond is formed when electrons are transferred between atoms. So what happens is that the cation, the positive ion, gives its electrons to the anion, or the negative ion. So atoms that create ionic bonds need to have their positive and negative charges cancel out, so they create a neutral compound. And the easiest way to figure out if it'll make a neutral compound is that the sum, which means we're going to be doing addition, of the oxidation numbers of the atoms have to equal 0. So ionic compounds are created between a cation, which will always be a metal, and an anion, which are always nonmetals. And they're usually solids at room temperature. So for example, we have table salt, which is NaCl. So we have a metal from the left-hand side of the table, which make a cation, and an anion, nonmetal, from the right-hand side of the periodic table. There are two pretty basic rules to naming an ionic compound. The first thing we're going to do is when we look at a formula, we're going to write the full name of the first element, and the positive element always comes first. So for example, if I look at Li2S, I look at the first symbol and say, okay, well that's Li and that stands for lithium, and I'm just going to write lithium. The second step is to write the name of the second element, but we're going to use IDE as an ending. So if I have Li2S, I've already taken care of this part. My nonmetal anion is sulfur, but instead of sulfur, I'm going to write sulfide. Let's try that again with MgBr2. So Mg is a metal. It lives on the left-hand side of the periodic table, and I'm going to write its full name, which is magnesium. And bromine, which is on the right-hand side of the periodic table, is an anion, and I'm going to put an IDE ending, so it'll be bromide. Take a second and try to guess what CaO would be. If you guessed calcium oxide, you're correct. We wrote the first full name of the first element and then put an IDE ending on the second element. Now we're going to actually create these neutral ionic compounds. And the first step when I give you elements is that you're going to look up the oxidation numbers for each element. So if I look at the periodic table, I see that Ca is in group 2. And everyone in group 2 has a +2 oxidation number because they have 2 valence electrons. So the oxidation number for one calcium atom is +2. For chlorine, if I look at the periodic table, it's in group 17, so it has 7 valence electrons, so it has an oxidation number of -1. There's a really easy way to figure out how much you need of each atom. So what we're going to do is we're going to drag just the number for the chlorine up to calcium, and then drag just the number for calcium down to chlorine. In essence, what we're doing is we're flipping the number. In order to write the formula, we're going to write the symbol for the positive oxidation number first. So if we look at our oxidation numbers, Ca is positive. so it goes first. And then Cl is negative, so that goes second. And that's step 3, so write the symbol of the negative oxidation number second. The fourth step says, remember that ionic atoms must form neutral compounds. So if I have one atom of Ca at +2 and one atom of Cl at -1, that's not going to get me to 0. But the reason we flipped it was because this tells me I need 2 atoms of chlorine in order to make a neutral ionic compound. If we look at Be on the periodic table, we'll see that it's also in group 2, so it has an oxidation number of +2 as well. And then oxygen is in group 16, so it has 6 valence electrons, so its oxidation number is -2. You might be tempted to flip it, so you'll have 2 of each atom, but this is the exception to the flip rule. So if we have the same number but with opposite charges, we just need 1 of each atom, because 1 of each atom will cancel each other out. So to write my formula, I put my +1 first, so Be, and then I put my -1 second, so O. And then you're done, because you only need 1 of each atom. Let's do one more together. If I have P, then I need to look at the periodic table, and I see that P phosphorus is in group 15, so it has 5 valence electrons, so it has a -3 oxidation number. While Ba, if I look at the periodic table, it's barium in group 2, so it has a +2 oxidation number. What I'm going to do is I'm just going to take the numbers and I'm going to flip them. So I'm going to put 2 up here and 3 down here. When I write my formula, I have to remember to put the +1 first. So Ba is actually going to come first here. And I need 3 Ba atoms to neutralize 2 phosphorus atoms. On a separate sheet of paper, I would really like you to try these 3 examples. So you should pause the video and then review them by pressing play again. By looking at the periodic table, we can see that the oxidation number for bromine is -1 and for potassium it's +1. Because it's the same number with opposite charges, we only need 1 of each atom. And even if you flipped it, you'd still get the same, so you really couldn't screw that one up. When we write a formula, we always put our positive cation first, which is potassium, and our negative anion second, which is bromine. So I only need 1 of each atom, so I don't need to worry about subscripts. And then when we name this stuff, KBr would be potassium bromide. The second set is aluminum and bromine. By looking at the periodic table, I see that aluminum is +3 and bromine is -1. Now, if I had just 1 of each of these atoms, I wouldn't get a neutral compound. So what I'm going to have to do is I'm going to have to flip these 2 numbers. So 1 from bromine would go up here to be aluminum subscript, and then the 3 would become bromine subscript. Like we've done before, aluminum will come first because he's the cation, or the positive ion. And then bromine comes second because he's the negative anion. And we'll have to have 3 bromines. And the name of this compound would be aluminum bromide. And last but not least, if we have sulfur, if I look at the periodic table, its oxidation number is -2. And sodium is +1. If I have 1 atom of sulfur at -2 and 1 atom of sodium at +1, I'm not going to have a neutral compound. I'm going to need more sodium, and I'm going to need 2 of them. Brought that 1 down, and then I'll bring the 1 up. So the positive cation always comes first, and I need 2 sodiums for every 1 sulfur. And the name would be sodium sulfide. Now that was just for monatomic ions. The next step is polyatomic. So you should have a reference sheet, or you can look these up. When you see something that's more than 1 atom chemically bonded together, but it's given as 1 anion or even 1 cation, it has an overall charge that we'll give you. You don't have to figure it out. So aluminum is a monatomic ion, or a single element, and I know this because there's only 1 capital letter. So aluminum's oxidation number, according to the periodic table, is +3. PO4 is more than one capital letter bonded together, so it's a polyatomic ion. For this, I'd have to look at my reference sheet that my teacher gave me or Google it. And if I Google it, I see that it has a special name called phosphate, and it has an overall oxidation number of -3. Luckily for us, in terms of creating a compound, it's the same number with opposite charges, so I only need one of each. The same formula building rules apply. The positive always comes first, so aluminum will come first in our compound, with PO4 coming second. And the naming is pretty similar too. We're going to keep the first full name, so aluminum is what we're going to write down first. But because PO4 has a special name, we're going to keep that as well. So we're just going to write phosphate for our anion. So the name of this compound is aluminum phosphate. Let's do the next one. If we look at NH4 and we look it up, we'll see that it has a special name called ammonium. And that one nitrogen bonded to 4 hydrogens has an overall charge of +1. Oxygen is a single element because it's only one capital letter, and it has an oxidation number according to the periodic table of -2. Well, if one ammonium is +1 and one oxygen is -2, I'm going to need one more ammonium to balance out this negative oxygen atom. But if I write NH4 and I need 2 sets of them, that looks like I have 1 nitrogen and 42 hydrogens. That's a lot of hydrogens. So I'm going to have to input parentheses around the NH4, so with the 2 on the outside. So this 2 on the outside of the parentheses tells me I have 2 sets of ammonia, which is what I need. And then I just add the oxygen at the end. So because NH4 has a special name, we're going to keep it. So we're going to start our formula name with ammonium. But because our anion is a single atom, we're going to use the IDE ending. So it'll be ammonium oxide. Let's do the last one together. Hydrogen is a single element because I know it's only one capital letter. So I'm going to look at my periodic table for its oxidation number. And because it's in group 1, it has a +1 oxidation charge. CN is 2 atoms bonded together to make a polyatomic ion and has a special name called cyanide. And one C and one N bonded together have an overall charge of -1. Now they're the same number with opposite charges, so you only need one of each. And the positive one comes first in the formula, so H comes first, followed by a CN. And then naming, first name of the cation, which is hydrogen, and because our anion is polyatomic and it has a special name, we're going to keep it. So our formula name is hydrogen cyanide.